What's up guys, and welcome to this video on question 2 of the 2018 DBE exam. The question is on, to me it looks like it's on forces and Newton's laws. Okay, so let's get into it. Block P of unknown mass is placed on a rough surface. Okay, so this surface here is rough and is connected to a second block of 3 kilograms by a light string passing over a light frictionless pulley as shown. Cool stuff. Initially the system of masses is held stationary with the 3 kilogram block 0.5 meters above the ground. So basically we know that the initial velocity is 0 and that S is 0.5 meters above the ground. When the system is released, the 3 kilogram block moves vertically downwards and strikes the ground 3 seconds later. So it takes time equals 3 seconds. Okay, so if we start off with a definition, question 2.1, define acceleration. So acceleration is the rate of change of velocity. Okay, and we get ourselves 2 marks for that. Okay, next question 2.2 says calculate the magnitude. So we want the scalar of the acceleration of the 3 kilogram block using the equations of motion. Okay, so equations of motion tells us we need to use our UVATs. Okay, and we're going to take downwards as being positive. Okay, our initial velocity is 0 because it starts from rest. Our final velocity is unknown. The acceleration is what we're looking for. Time is 3 seconds, and our displacement is 0.5 meters. Okay, so what equation can we use? Let's use the equation S is equal to ut plus a half at squared. Okay, u is 0, so that term goes to 0. So we can say that a is equal to, let's see, 2s over t squared. So if we plug in values, that's 2 times 0.5 all over 3 squared. And if we plug that into our calculator, we get a value of 0.11 units of meters per second squared. Okay, and that's our acceleration. And once again, they only want the magnitude, so we don't have to care about the direction, but if we did, the direction would be downwards. Okay, so we get 3 marks, quite generous there. Okay, then we want to calculate the tension in the string. Okay, so what we can say is, so question 2.3, we can use Newton's laws here, and we can say that the sum of the forces, and let's take downwards as being positive, is equal to my mass times my acceleration, with downwards being positive. Okay, so if I had to draw a quick free body diagram here, we have weight acting downwards. Okay, and we have tension acting upwards. Okay, and the tension must be less than weight. So I'm going to say that weight minus tension is equal to mass times acceleration. So my weight is going to be mg, and then I'm going to manipulate this equation, so minus ma is equal to my tension. So tension is equal to my mass, which is 3 kilograms. Okay, let's just do mass. So mg minus ma. Okay, so T is equal to my mass, which is 3, times gravity, which is 9,81, minus 3 times my acceleration was 0,11. So that means my tension, if I plug this into my calculator, I get a value of 29,07 newtons. Okay, and that is the answer for that. Again, the tension, it's only the magnitude we care about, but if we wanted it as a vector, the direction for tension for the 3 kilogram block would have to be upwards. Okay, cool stuff. So moving on to the next question. the magnitude of the kinetic friction experienced by block P is 27 newtons. Okay, so the frictional force is 27 newtons. Draw a labeled free body diagram for block P. Okay, so let's understand what's happening. If this 3 kilogram mass is moving downwards, that means that block P is moving to the right. Okay, so what we have is we're going to have our, so we want to draw a free body diagram. So first we're going to start off with our tension, which is pulling the block to the right, and then the force friction is preventing it. Force friction is preventing it from moving, and we know that has a value of 27 newtons, and the tension has a value of 29.07 newtons. Okay, so we also know that there is a weight acting downwards, weight, and we know that that is our normal force. Okay, so the normal and the weight must be equal, whereas our tensional force is greater than our force of friction. Okay, so that might be important for us to note. Okay, so next it says calculate, and we get 4 marks for that, so cool. Then it says calculate the mass of block P. Okay, so how are we going to do this? Again, we can go to Newton's laws, and this is 2.5, and this was 2.4. Okay, so we want to calculate the mass of block P. So we can say that the sum of the forces in the rightwards direction is equal to my mass times my acceleration in the rightwards direction. Okay, so another thing to note is that if this block has an acceleration is equal to 0.11, that means that block P also has an acceleration which is equal to 0.11. Okay, so now we want to solve for the mass. Okay, so my tension minus my force of friction is equal to my mass times my acceleration. So my acceleration is equal to tension minus my force friction over my we want to solve for the mass over my acceleration. So tension was 29.07 minus 27 all over my acceleration, which was 0.11. So we can solve for my mass, and let's plug this into my calculator, and we get a value of 18.82 kilograms. And that is the final answer. Okay, and with that we get ourselves 3 marks, and we total 15 marks for that question. So not too difficult, quite a nice question. Yeah, so a little bit of thinking, but other than that, quite easy. And in the next video we will go over question 3. Okay, thanks for watching, guys.